Hello dear viewers, welcome to TV Math Hub. In our today's session, we shall be looking at question number 9 for UNEB 2025 Pure Mathematics. So this is the UNEB paper that has been recently done by the Series 6 Mathematics candidates countrywide, and we are looking at the solutions. Please consider subscribing to this channel so you shouldn't be missing any of our videos pertaining the solutions to this given paper. So let us look at question number 9. It says evaluate the integral of 0 to pi by 4 2 cos squared x plus sine squared over 1 plus cos squared x dx. It is taking 5 marks. So let us see how best we can get these 5 marks. So looking at what we are having, we can easily say that this definite integral can be simplified by looking at manipulation of the integrand that is given. So basically, we shall try to simplify what we have here. So we have from 0 to pi by 4. 2 cos squared, I want to put everything in terms of cos. So this is same as 2 cos squared of x plus sine squared can be written as 1 minus cos squared of x, and we divide this by 1 plus cos squared of x dx. So from here, that is when we substitute using the Pythagorean identity. So from that, we can easily see this is 0 to pi by 4. This will give us cos squared of x plus 1 divided by 1 plus cos squared of x dx. And when you look at what we shall have here, this is actually same as 1. So this is 0 to pi by 4 of 1 times dx, because this is 1 plus cos squared over 1 plus cos squared. So this will give us integrate 1 with respect to x. That will be x from 0 to pi by 4. And this will be same as having pi by 4 minus 0, which will give us pi by 4. And that will be the required answer. Having looked at 9 part A, we shall look at 9 part B, which says find the integral of x squared, the ln of 1 minus x squared dx. So to look at the solution for this, we shall basically say that this indefinite integral will require us to use what we call the integration by parts. And for that case, it means this is same as having uv minus the integral v du dx then times dx. Now, which means that we need to get our u and to get our v. So since we are having a polynomial with a natural logarithm, then the natural logarithm will be the function, because this can be easily differentiated, but you cannot easily integrate it. So we shall let u to be ln of 1 minus x squared. And for that case, the v dx will be x squared. So from there, it implies that our v will actually be x to power 3 divided by 3. And our du dx will actually be, differentiate this, get minus 2x divided by 1 minus x squared. So basically that is what we shall have, and this will imply that the integral of x squared ln of 1 minus x squared dx will be same as u. Our u is ln of 1 minus x squared times v, which is x to power 3 divided by 3, minus the integral of v, that is x to power 3 divided by 3, and then times negative 2x divided by 1 minus x squared. So from here, we can try to rearrange this to be x to power 3 divided by 3, ln of 1 minus x squared. Then minus, we can have this as a plus, then a third out, actually 2 out of 3 out. Then the integral of x to power 4 divided by 1 minus x squared dx. So that is what we are having so far. So from what we have, you realize that this side here, we have the integral of x to power 4 over 1 minus x squared. So we shall use wrong division from this given point. So I want to call this one equation star. So I want to first of all express this one here in terms of a wrong division, since it is an improper fraction. So let us simplify. X to power 4 over 1 minus x squared using a wrong division. So having this, we shall therefore have to use wrong division here. So this is x to power 4. We have 1 minus x squared. So we use wrong division, and using wrong division, it means here we shall have to put negative of x squared. When you multiply it here, it will, when you multiply it with this, it will give us x to power 4. When you multiply it with this, you'll get minus x squared. So from there, we shall subtract. This will give us 0. Of course, this will be x squared. So here we shall again apply. We need a positive value. So let us put negative 1. When you multiply it here, it is x squared. You multiply it with this, it is minus 1. So this will give us 0 again. When you subtract, we remain with positive 1. So in other words, x to power 4 divided by 1 minus x squared is same as having a negative x squared minus 1, then plus 1 upon 1 minus x squared. So we shall again come back to equation star. We shall come back to equation star, and we shall have from equation star, we shall have the integral of x squared ln of 1 minus x squared dx to be same as so it will be x to power 3 divided by 3. It will be, so from our equation star, we shall be able to substitute this back. And when we substitute this back, we have seen x to power 4 over 1 minus x squared. It gave us this negative x squared minus 1 plus 1 upon 1 minus x squared. So that is what we shall put here. And from this, we can easily say this can be easily integrated, and this can be easily integrated as well. So this will be same as writing x to power 3 over 3 ln of 1 minus x squared plus 2 over 3 the integral of negative x squared minus 1 dx plus 2 over 3 the integral of 1 upon 1 minus x squared dx. So we shall call this one equation number 1. So it means this can be easily integrated, but we are remaining with this given expression as well. So what we shall do from here, from this given point, we shall have to again consider, 1 upon 1 minus x squared, and put this in terms of partial fractions. And before that, we can see that 1 over 1 minus x squared is same as 1 over 1 minus x into 1 plus x. It is same as this. So this can be expressed in terms of partial as a over 1 minus x, then plus b over 1 plus x. So this is 1 over 1 minus x into 1 plus x. So from here, we shall go on and have this as 1, which is equal to a into 1 plus x plus b into 1 minus x. So we want to get the values of a and b. So a over 1 minus x, then plus b over 1 plus x. So you cross multiply. So 1 is equal to a into 1 plus x, then b into 1 minus x. So from here, we can easily say that for x equaling to negative 1, 1 will be equal to, so this will go away. We shall have b into 2. And this implies that b is same as a half. Likewise, for x equaling to 1, we shall have 1 which is equal to 2a, and this will imply that our a will be a half. So this implies that 1 upon 1 minus x into 1 plus x is equivalent to having a half over 1 minus x plus a half over 1 plus x. So from this given point, we can get the integral of this. So we can say the integral of 1 upon 1 minus x squared dx is actually same as integrating a half over 1 minus x, then plus a half over 1 plus x, the whole of this into dx. So this is same as a half times this will be actually negative a half ln of 1 minus x, because the derivative of this is supposed to be a negative 1. So plus a half ln of 1 plus x. So in other words, you can have this as negative a half ln, you can use magnitude because we want to avoid a minus here, 1 minus x plus a half ln of magnitude of 1 plus x. So actually this is same as having a half ln of this one here, 1 plus x over 1 minus x. So this is what basically we shall get. So from equation, so next we shall say we have got this. So this is the integral of 1 upon 1 minus x squared dx. So now next we can try to have from equation 1 we shall have from equation 1 we have this, we shall integrate now and substitute also for this. We have already got this. This can be easily integrated, so let us rewrite that and get. So from equation 1 we shall have this, we have x to the power 3 over 3 ln of that plus 2 over 3, we shall integrate this to have x to the power 3 over 3 minus of x, then plus 2 over 3, the integral of this, we have got it also here. So this is a half ln of 1 plus x upon 1 minus x. So it means we shall have 2 over 3 times a half ln of that. So when you simplify this, it will give us x to the power 3 over 3 ln of 1 so 1 minus x squared plus we can even put this minus out, so we can have this as minus 2 over 3 of this one here. So this will be x to the power 3 over 3, then plus x, then plus this can be simplified to give us a third ln magnitude of x plus 1 over x minus 1 plus c. So that would be the value of the magnitude of x squared ln of 1 minus x squared. If you simplify it further, then you will have it as x to the power 3 over 3 ln of 1 minus x squared. This will be minus 2 over 9 x to the power 3 minus 2 over 3 of x, and plus a third ln of magnitude of x plus 1 over x minus 1 and then plus c. So that basically is the answer. So this will be the answer of integral of x squared ln of 1 minus x squared dx. So we shall look at question number 10, which says find the Cartesian equation of the curve, which is described by this, where w is a complex number, x plus iy. So we shall look at the solution. So we are told that a magnitude of y minus 3 plus 6i is equal to 2 magnitude of y. So we are told that y is same as this, and for that case we shall substitute for that y and have magnitude of x plus iy minus 3 plus 6i will be equal to 2 magnitude of x plus iy. So this will be same as having magnitude of x minus 3, correct the real part alone, and the imaginary part, that is y plus 6 into I. So this is same as 2 magnitude of x plus iy. So from here we shall remove the magnitude. You know, magnitude of a complex number, which is magnitude of x plus iy, is same as having the square root of x squared plus y squared. So for that case, this is same as having the square root of x minus 3 squared plus y plus 6 squared. And this is same as 2 square root of x squared plus y squared. So from here we shall square on both sides. From here we shall square on both sides. So squaring on both sides, squaring on both sides, we shall be able to get x minus 3 squared plus y plus 6 squared, which is equal to 2 squared into x squared plus y squared. So this can be simplified further to give us x squared minus 6x plus 9 plus y squared plus 12y plus 36 will be equal to 4x squared plus 4y squared. So let us try to simplify by taking everything the other side, and this will give us 3x squared plus 3y squared. Take this one the other side, gives you positive 6x. Take this one the other side, gives you minus 12y. This is 45, so it becomes minus of 45, which is equal to 0. So from here you can divide through by 3. So that is x squared plus y squared plus 2x minus 4y. Then minus 15 will be equal to 0. So from here, so this is basically the Cartesian equation of the curve. However, we can go on and find what this Cartesian equation of the curve represents. So to do that, we shall try to simplify this. So with this given expression, you can have it as x squared plus 2x, then plus y squared, then minus 4y, which is actually equal to 15. So from here, you can use completing squares. This is same as x squared plus 2x plus 1 squared minus 1 squared, then plus y squared minus 4y. So get the half of this, that is plus 2 squared, then minus 2 squared, which is equal to 15. So from here, this alone is same as x plus 1 squared. This alone is same as y minus 2 squared. And this will be equal to 15 plus 4 plus 1. So when I take this one to the other side, I take this to the other side. So I will get x plus 1 squared plus y minus 2 squared, which is equal to 20. So from this, we can easily see that the Cartesian equation of the curve is actually a circle with center -1, 2, and radius, which is square root of 20. So this is actually the equation. This is the equation of the circle. Equation of the circle with center. This is actually equation of the circle with center -1 and 2, radius and radius and radius, which is equal to the square root of 20. And this can be same as 2 square root of 5 units. So the Cartesian equation of the curve is actually a circle that has got center -1 and 2 and radius, which is 2 square root of 2. So that is all about this part here. That is all about part A. So we look at part B. So for part B, we need to use the Moivre theorem to simplify this. Cos 3 theta plus I sine of theta over cos 5 theta minus I sine of 5 as theta. So let us look at the solution. So looking at this, we are given a cos of 3 theta plus I sine of theta divided by cos of 5 theta. So I can write this as cos of 5 theta plus I sine of actually -5 theta. So cos of a positive angle is same as cos of a negative angle. So likewise, I can write this as -5 theta, because cos of a negative and cos of a positive are actually the same. So looking at what we are having, you realize that this is 3 theta, but this one here is theta. So since it is given like this, we shall also continue solving it the way it is. Otherwise, if this was 3 here, if this was 3, then it would be easy. You also pull out the 3. But since it is not, then we shall maintain this one the way it is. Otherwise, you are not supposed, you can't place a 3 here if it is not given. So this can be written as cos of theta plus I sine of theta, and this one here is to power -5. So using de Moivre's theorem, or we can write that. So from here, if this one was a 3, then you would also put this one out, then it can be easily simplified. But since this is the way it is given, please maintain it the way it is given. So this is cos 3 theta plus I sine of theta. We can bring this one up and have this as cos of theta plus I sine of theta to the power of 5. Since we cannot easily combine this and this, we can again have this as, we can again have this in terms of de Moivre's. Using de Moivre's theorem, we can have this as cos of 5 theta plus I sine of 5 theta. So that is basically what we can do there, since we cannot easily combine this and this. So from here we can try to simplify this expression by multiplying. So we shall get cos 3 theta, we multiply it with this. So I will try to expand that. So this will be cos of 3 theta, cos of 5 theta. We multiply this with that. It will be I cos of 3 theta, sine of 5 theta. Then we multiply this and this. This will be I sine of theta, cos of 5 theta. We shall add there this and this. That is I squared sine of theta, then sine of 5 theta. So this would be same as having cos of 3 theta, cos of 5 theta, then minus this will be sine 5 theta, then sine of theta. So we shall add there I into this is cos 3 theta, sine of 5 theta, then plus cos 5 theta, sine of theta. So that is basically what we shall have from this given point. So from this given point, we can again try to simplify this further. So this will be again same as having when you have this one here, when you have cos 5 theta, cos 3 theta, it can be easily written as a half into cos 5 theta, cos 3 theta, that is cos of 8 theta plus cos of, so we are trying to put this one back in its original form. So cos 3 theta, cos 5 theta, if you have this is cos cos, so it comes from cos plus cos. So that is 5 theta, that is 8 theta, then 2 theta. So it means it will be cos 8 theta, then plus cos of 2 theta. When you expand this, you should be able to come back at cos 5 theta, cos of 3 theta. Then again, we are having this minus of this. So this is same as, so it should be minus 2, so that is plus a half into, so that is plus a half into, so this is sine 5 theta, sine of theta, so it comes from cos minus cos, so that will be cos 6 theta minus cos of, so 5 theta plus that is 6 theta, then 5 theta minus that is 4 theta. So this will come from a half cos of 6 theta minus cos of 4 theta. So that is where this one comes from. So next we shall have I, this is sine 5 theta, cos 3 theta. So next is plus I into, so here you are having cos sine 5 theta, cos 3 theta. So that one comes from sine plus sine. So there must be a half first. So let's put a half first here to have this as a half into, so this will be sine is bigger than cos, so it comes from sine a sine plus sine. So that is a sine 8 theta. That is 5 theta plus 3 theta, sine 8 theta, sine 8 theta plus a sine of 5 theta minus 3 theta, that will be 2 theta. So next we shall have a plus a half. So next we are having cos 5 theta sine of theta. Cos 5 theta sine of theta, cos is bigger, so that will be a sine. So we are having cos 5 theta, so that is 5 plus this, that is 6, that is 4. So that is sine of 6 theta minus sine of, so next is 5 minus, that is 4. So minus sine of 4 theta. So this is all into I. So from here we can have a half into, so everything will be into cos 8 theta, then plus cos 6 theta, plus cos 2 theta, minus cos of 4 theta. Then plus a half. So we can also put I. So this is I into a sine of 8 theta plus sine of 6 theta plus sine of 2 theta minus sine of 4 theta. And basically that will be our answer. So this can be finally written as a half into, this will be a half into a cos of 8 theta, cos of 6 theta plus cos of 2 theta minus cos of 4 theta plus I into a sine of 8 theta plus sine of 6 theta plus sine of 2 theta minus sine of 4 theta. So that is basically what we shall get, and that will be the answer to cos, this will be the answer to cos of 3 theta plus I sine of theta over a cos of 5 theta plus, this is minus I sine of 5 theta. So that would be the answer. However, we note that there was an error on sine of theta. This is supposed to be 3, and this would be easily simplified. This would be easily simplified by using the Moivre's theorem. But now, since the error is there, you have to maintain what is given. So you don't need to think about the 3. So if you maintain what is given, then you do the simplification. And when you do the simplification following the same procedures, then you'll be able to move up to this. Yeah.